Hi, everyone. Welcome to Stem From's podcast, Where Does Your Journey Stem From? Hosted by myself, Dr. Karina Minardi. Today, we are joined by Rachel, who is currently studying at the University of Nevada at Reno. Let's welcome to the stage, Rachel.
Hi.
Hey, Rachel. Rachel Kozloski is a PhD student at the University of Nevada at Reno's graduate program of hydraulic sciences. Prior to beginning her PhD, Rachel worked in the private and government sectors as a soil scientist and environmental analyst. Her research focuses on microplastics in urban runoff and microplastic movement in connected surface and groundwater systems. When she is not conducting lab analyses or doing field work, she is equally happy exploring wild places or curled up with her dogs and a great book. So that's a great explanation of you, Rachel. Welcome to the podcast. I hope that we can then start off with our first question that we always start off with guests. Tell us a little bit about yourself, your background, and you as a person.
Oh, thank you. I'm super excited to be here. About myself. I'm I am just a very curious person. I'm one of those people that's just always getting myself into trouble with asking too many questions. I love I love exploring in almost any space, whether it's the books I'm reading or um, the outside environment or just pushing myself to learn something new. I think that's really one of the things that's just pushed me for my whole life.
Well, tell us a little bit more about yourself and I think your proclivities to nature are obvious. Wild adventures are obvious, but was that always the case when you were a kid, or was that something that was ingrained with you as you became older?
Yeah. I grew up as a farm kid in Northern California, Northeastern California. So grew up um, working on ranches and tractors and spending a lot of time outside, a lot of time managing soils and water. So it's not surprising that that's sort of where I ended up. My family was always um, really out in the world, just out in the woods, out hiking, out fishing, camping, just spending a lot of time out in nature. So it's definitely something that was ingrained in me, I think, from the time I was a little kid. And it's free, for rural people growing up in the middle of the nowhere. It's free entertainment. So we spend a lot of time out. Um, yeah, I think that's one of the things that's probably definitely had a big influence on my career trajectory. Just that love of nature and love of those environments you see out there and the desire to protect them and keep them available for everyone to enjoy.
No, absolutely. I think that's obviously tantamount to hopefully many people, obviously in America and beyond. So as my intro, I think, lent itself to, you've worked in public private institutions.
Mm.
What did you like? What was good, bad, maybe even the ugly from any of those
Yeah, good,
experiences
bad,
from a
ugly.
background prior to your PhD?
Sure. Yeah, let's see. I finished okay, let me go all the way back to the beginning. So when I first went to college, I was really interested in airplanes. And so I started in aviation design and aviation technology, and I was in that track for about 3 years before I realized it really wasn't what I wanted. Took some time off and worked in the woods building trails in New Mexico and um kind of had some time to think about what I wanted, and then I went back and finished my degree at University of Wyoming, studying soil science. Um, and then when I got out, I had a bunch of advisors and other students just really encouraging me to pursue grad school. But at that point, I had so much debt from 6 years of undergrad, maybe not making the best financial choices and the type of schools that I went to. So I had a lot of debt and I was really stressed about it. So even though I had people encouraging me to go to grad school, I just I couldn't I couldn't get my head around it. And I also couldn't get around my head around the idea that it wasn't something I was necessarily going to have to bankroll myself. Um, for me, that was a new concept, and I really didn't understand it until honestly just a few years before I went back to school. So I thought all I could think about was the cost and how far in debt I was and how badly I needed to dig myself out. So I left school with my degree, and I started working. Started off first for the Forest Service, and I spent a few years there doing timber cruising, which was not in line with my degree at all, but it was the work I could find at the time. My partner had sort of supported me while I was going through my finishing up school, and so then when we were done, I just said, "Hey, where do you want to go? I'll follow you this time." So he got a job in an area, and I just kind of scrounged till I could find something that worked for me. So was timber cruising for a few years till I was definitely really, really bored of painting trees. Um, and uh, I had heard about this consulting firm down in Carson City, not too about 45 minutes away from where we were living. I had heard they had a good reputation, and so I essentially just hounded them until they hired me. I would go down every month and I'd drop my resume off again, even though they already had it, and I'd say, "Hi, soil scientist, want to work for you, hire me." And they would say every time, we don't have any positions right now, but we'll keep your resume." And so I just kept doing that until I finally got a call and they just said, "Well, we have some work. I mean, might not be exactly what you're looking for, but we could fit you in." And it took off from there. So worked for that consulting firm. They were great people, very kind. I learned a ton. I got a lot of experience doing, field work, collecting rangeland data, soils data, biological data of various types, working on different projects, and really sharpening my analysis skills, like my written analysis skills and my like geospatial skills, which I were non-existent before that point, really. So I learned a ton, but by about the third year of working for that consulting firm, I realized that the work I really wanted to do was going to need a graduate degree. um, so I started to realize that I need more skills that I can't get through just working in order to pursue the type of work that I want. Unfortunately, well, not unfortunately, it made it complicated, but around that same time, I had my first child. And so at that point, I had a baby, full-time job, and this desire to do more, but knowing that now is not the time to go back to grad school. I know there are people that do it. For me, I was in survival mode. So I stayed in consulting. But then I thought, well, what else can I do that doesn't require me to go back to grad school? So at that point, I went for my certified professional soil scientist um, designation, which it's sort of similar to an engineering license where you you have apprenticeship level. And then after 5 years of experience in the field and another very rigorous test, you can be certified. So I started that. It took me a while. But in that process, I realized that I wasn't getting enough soils work through the consulting firm I was with in order to complete my certified professional soil scientist. I wanted that. Um, but I was doing so much rangeland and GIS work that although I was getting some soils work with the consulting firm, I wasn't getting what I needed in order to meet my 5-year in the field requirement to get my license. So then I went to work for the Natural Resources Conservation Service, which is another government organization, because they were hiring a soil scientist. And so I got a 2-year position with them. It was just term. But I got to work with one of the soil scientists in our region who had just finished a huge mapping effort for the area and was a great soil taxonomist, a really creative person. And so just spending that time working underneath a soil scientist and being really focused on soils in general was what I needed to finish my certification and get licensed there. So that was that job. So my first round in consulting, I loved the people. I worked for an really great organization, um, but it wasn't the work I wanted. And then I worked in the NRCS, and it was also great people. I learned a ton. Also wasn't quite what I wanted. It just didn't fit right. Um, and then when that term position ended, I had to sort of choose between taking a permanent position with them, which would require me to move. I think the place they offered me was Blythe, which if you know California at all, it's a very dry desert area. Lots of irrigation and agriculture, but it's pretty bleak. So I wasn't ready to leave Tahoe and go live in Blythe. Um, so I stayed, and when I stayed, I went back to what I knew how to do, which was consulting. So, I ended up with another consulting firm, even though at this point, again, like me and my partner, we were sitting down trying to figure it out. Like I knew I really wanted to go back to grad school, but I couldn't figure out how to make it work. Again, at this point, I had 2 small kids and, just trying to keep my head above water. It's very expensive where we were living. It was tough, and we just weren't at a place where I could take the time I needed for myself to be able to pursue a degree. So, back to consulting. I was lucky. I think I've been very lucky in my career so far that both of the consulting firms that I worked for were really, really ethical, really great groups to work for. I was never pushed to, um, come up with data or come up with answers that fit the client's need. It was always very much do your best work, do your best analysis, and it is what it is. So I feel really fortunate that there's been sometimes you hear stories from other situations, and I'm really grateful for the people that I worked with. But again, it wasn't what I wanted. It was what met the need at the time. Worked with great people, learned a lot. My boss, at my second consulting firm figured out pretty early on that I was hungry for hard questions, and I would solve anything that she would throw at me. So I got a lot of those whenever there was a complicated project. That was often where they'd say, "Hey, this one, we're not sure how to approach this one. Do you wanna take a stab at it?" And, having that sort of freedom really allowed me to push myself and grow, and I learned a lot from that work environment as well. I became a lot better writer. I became a good project manager. I continued to develop my field and my technical skills. A lot of good came out of it. I definitely learned a ton. But it wasn't meeting that need that I had in my brain, in myself for pursuing the questions that I'm interested in, for my engaging my curiosity. It's a lot of, just kind of plug and play work. So, yeah, I got to a point in my second consulting gig where, um, I just I had done it for about 9 years by that point. My kids were old enough, they didn't need me as intensely, and I desperately needed to do something different, for my brain. a chance to just pursue something that I was passionate about. Um, and so we decided, like, me and my partner sat down again and we had, well, we've got some money in savings. We've got, it's you've been doing this for a really long time. Let's just see if we can make it work. And so I started looking at grad schools at that point. I would say, like, the good and the bad, there were definitely good things about working in government service. Um, I felt very taken care of a lot of the time. Um, I had good opportunities to travel to different locations and work with different people. But then again, I think the thing that you always hear about that is the bureaucracy is hard to deal with, and like anyone will tell you, yeah, that's absolutely the case. But there's pros and cons, I think, with everything. And with consulting, I loved having a new project every every couple months. Something new would come onto my plate. Something would move off and something new would come in. So the variety of the work and, the people I got to work with, that I got to work all over the Western states, that was really great. I learned a ton. With consulting, the trouble there, of course, is the, fast pace and the late nights and the evenings and really, having to work really hard to meet deadlines, that aren't necessarily being met on the other end. When we were always very committed to meeting the targets that we had, but sometimes it didn't necessarily need to the client wasn't necessarily doing the same, so that was hard, but good. So, hard and good, I think, across all these different, um, groups that I've worked with. Um, so anyway, when I started thinking about grad school seriously again, I was researching several different programs, trying to find, I guess, figure out what I wanted. I had been working in soils for a long time, but especially in the Tahoe area and, California, there's a lot of focus on sediment movement, sediment transfer, and how that affects water quality, the effects of nutrient movement in sediments and how that affects water quality, and then also, just protecting water resources from a climate change and drought perspective. So my work had gradually shifted from soils to hydrology in my consulting environment, where I was learning more and more. I was working with hydrologists and modelers and working on groundwater work and uh, surface water protection and things like that. And uh, it just kind of took the place of my focus in soils and I really started to think more about how the 2 work together, um, rather than separating them, but how are our soils and our water resources connected? And, especially one of the questions that was really taking up space in my brain at that point was wondering about the impacts of groundwater recharge and managed aquifer recharge, which is something that we're doing in California and other Western states where when you have extra surface water, you can inject that or infiltrate that into shallow groundwater reserves so that it can be used later when you run out of surface water. It's an adaptation to take advantage of those resources so that municipalities and cities and water users can just plan better. And it's especially important as we think about climate change with the lack of snow or losing part of the snowpack, which is a huge water storage reservoir for the West. So as we're thinking about losing that resource, we have to think about what are we going to replace it with and where are we going to be able to store that water. So managed aquifer recharge or artificial recharge was one of those things I was really thinking a lot about. And at the same time, we started to talk about microplastics and other anthropogenic, um, contaminants that might move from our human-affected environment out into our natural resources, and so we're stuck in this situation where we know we need to make good use of our surface waters and or even recycled water, and try to be as efficient as possible, but also recognizing that there could be pollutants or contaminants that are getting into that. And if we're injecting that or infiltrating that into our groundwater, we could be cross-contaminating. So I was thinking about that question a lot, thinking about water resources and management. And then I saw that Dr. Monica Arienzo, University of Nevada, Reno, and Desert Research Institute, which in my consulting time, I was just a giant fangirl for Desert Research Institute out of Reno. Always watching the work they're doing and seeing really neat projects coming out and just sort of wishing I could be there. So I saw this PhD position fly. It was right up my alley. I had been applying for a couple others in the hydrology related field, but in Davis or in Montana and different schools. And then I saw this one and the date had just passed for the closure of the position. And I emailed, I was like, I saw this just passed, but would you consider my application anyway? Um, and they were gracious enough to allow me to apply, and I got in. So yeah, it was very exciting. It was a thing I have been waiting for so long. And a huge change for me, especially going back to school as a 40-year-old mom of teenagers, coming into a cohort of mostly 20-somethings who are still very fresh from um, all of their education and everything. I mean, for me, the last time I was in school was literally 20 years ago. Um, well, 23 years now. So, um, so it's been a while. I've definitely felt rusty. It was a big adjustment for me, for my brain, just trying to get back into that headspace of homework and deadlines and classwork and managing that while also learning to conduct really rigorous research, in a very different environment from the way that I'd been collecting fieldwork before. So yeah, lots of changes, lots of adjustment there.
So I guess the $1 million question then, and then I want to obviously hear more about your research now, is long term, are you considering going back to consulting post PhD?
Oh, I get asked that by my friends in consulting all the time. I think the answer is it depends. Really what drives me is that I want to be able to ask hard questions and do meaningful research. Um, and if a consulting position was more along the lines of, based on the work you've already done, bring your expertise and answer questions, but really not direct research, I don't think it's something I would be interested in. I want to, I mean, all things are subject to change, right? So at this point in my career, I'm loving being able to do research. I mean, even though for me it's long hours at a microscope or in the lab or coding or working with my data, I love it. I love the ability to just immerse myself in these questions and really dig into it. I think it's one of those things I think where because I wanted it for so long, and I was sort of dreaming of it from a distance, I'm just almost giddy sometimes when I'm able to just dig into this, dig into the questions, dig into my research, feel like I have time and space to really um, pursue the questions thoroughly. I think that's one of the difference and I know this isn't real, this isn't like um, how all research will go. Um, but for right now, in this PhD period of my life, I have the luxury of having time and one focus, and it's lovely. So, from right now, it's hard for me to think about not being in a research focused position. Um, but we'll see.
Yeah, time will only tell, right?
Yeah.
So Thank you for that pretty thorough review, not only of your history, but what drives you, some of the good and the bad. I think our listeners are really inclined to understanding, what is, let's do the real talk
Yeah.
about, what you've experienced throughout your life. And I know I appreciate it and I can emphasize with much of it. So let's actually do a little bit of a deep dive then on your current research, since you obviously love doing it and what you're currently doing. Um, let's actually talk. You gave a big overview of what you're doing, why you're doing what you're doing. But let's actually talk about some of your current specific research, some of your hypotheses. What are the results that
Yeah.
you're generating?
Mhm. Well, yeah. So I've got two big areas where I'm working on, and they're kind of interrelated. But the first area that I'm working on is fate and transport of microplastic and synthetic particles in the Mekong River in Cambodia. Um, you could generalize that by just saying in freshwater systems. But rivers are distinct from lakes, and all freshwater is a little different from the ocean system. So there is some classification going on there. The Mekong itself is especially interesting because it's one of the largest rivers in the world, and it's one of the most biodiverse rivers. And it's also in a really rapidly changing human environment. Cambodia went through a terrible period of civil war, and they have been, since the 70s, really building their economy. So um, they've been building their economy really rapidly. There's been a lot of urban growth and change in the country, agricultural change, industrial change, but um, there some of the basic services and um, like support side of the economy has been lacking. So one of the issues when we talk about plastic pollution is the connection between um, large plastics and the microplastics, the really small ones. So obviously, well, maybe it's not obvious, but the smaller plastics, the microplastics that I'm studying, generally the width of like 1 millimeter down to like the size of a bacteria or so. Um, they're for the most part formed from degeneration of larger plastics. So as your larger trash breaks down in the environment or your textiles shed fibers, um, tires wearing down on the roads, all of that creates plastic that gets released into the environment. So it's all like these macroplastics breaking down into these smaller fragments and then becoming difficult to manage because we can't see them, we can't filter them, we can't get them out without having, well, at scale, I guess uh, the right way to say that is we can't filter them out at scale that's meaningful. So in Cambodia, waste management is one of those industries that has really not grown at the same speed as the economy. So the folks that live there are an industrializing nation. They are consuming more. There's a lot more plastic being used in the country, but or there's not a sufficient waste management infrastructure there. So a lot of waste gets put into the rivers, much higher than in a lot of developed countries. And this is common across all Southeast Asia, all these rapidly developing areas. It's not just Cambodia specifically. It's just where my project happens to be. One other variable with the Mekong River especially is the monsoon and the seasonality of the river's flows. So you've got a very distinct dry season and a wet season. And in the wet season, when the river floods, um, there's a lot of the developed areas on the periphery of the river that are inundated or underwater. So you get a lot of material that could move in from those floodplain areas into the river itself. A lot of the waste that's piled up on the shores can get brought into the river. A lot of material that is sunk to the bottom of the river can be resuspended and carried. So My first question that I'm working on answering is how do the microplastic profile of these locations change relative to the seasonality of the river? So, how does it change in the dry season versus the wet season? And we're looking at the suspended particles, so the ones that are right on the surface. Um, so, it'll be really interesting to see whether or not we have um, more or less of suspended microplastics in the river during the wet and dry season, and then also whether or not the type of plastic that we have floating in there is changing based on the season. And because a lot of our higher density materials, they sink down to the bottom, but during the high flows, they can get um, resuspended and brought up to the surface. So that's important for understanding because the different plastic materials have different effects. You kind of think about plastic in general as, one thing, but in actuality, there's a huge chemical difference between like polyethylene and PVC, um, or even silicon and PVC. Some of them are relatively inert in the environment, and they don't have a lot of additives, or they don't have um, compounds in them that can leach out. And some of them are, like PVC, for example, is almost in some cases it can be more than a third of the actual material is just additives, things, chemicals added to it to make it flexible, to make it last longer in UV light, just to meet the manufacturer's specifications. So the problem is that those compounds can act differently in the environment once they break free from the plastic itself, from those polymers, and they get pulled into the environment. They can have different ecological effects. So understanding which plastics are available at which times is important for understanding the potential impacts on the people and the um, aquatic life that's in that system.
So thank you for that. Um, I guess my next question would be is since your research is in Cambodia, but you're in Reno, how do you actually facilitate your research?
So I've already collected all of my samples. I was very lucky. So at the University of Nevada, Reno, there's a program here by two professors that started working on the Mekong in like the early 2000s. So they've been there for more than 20 years, working with the local populations and local scientists, building an extension branch in this capital city of Phnom Penh, working with graduate students and postdocs and professors in Cambodia, Cambodian nationals, to look at fisheries and sustainability and um, a bunch of important aquatic parameters on the Mekong itself. And like I said before, the Mekong's one of the most biodiverse rivers in the world. So it's really been important to study it, especially as industrialization happens and more dams get added to the river. The part of the river we were able to study is actually the longest dam-free section in the Mekong. It's about 575 kilometers from the Lao border to the Vietnam border in Cambodia. So this was one of those things, part of this kind of serendipity of falling into this project through my PhD work. I was just getting started, and the opportunity came up. Wonders of the Mekong, this group that we're working with, they said, "Hey, we have this 2-week-long expedition down the length of the Mekong to collect a bunch of biological samples and parameters for algae and fish populations. Would you like to join? And you could look at microplastics." So the answer, of course, was yes. Of course, I would join. So we jumped in, worked with my whole lab group, sort of tag team this because it was multiple trips, long trips, and then also exploratory trip to start with to make sure that we knew how and what we were going to be collecting. So it was a lot of trips to Cambodia. Um, so in last year and the winter before was when we collected all of our Cambodia samples. So I have them all. Now they're all in the lab, and I've been working through processing them. And it was a great experience. I mean, especially as a first year PhD student, to be able to go to Cambodia, work with a bunch of really great scientists and collect um, just really exciting data in a place I'd never thought I'd be. So, so yeah, so I've already collected my samples. Now I'm in the um, lab microscope and data crunching phase of my work. Um, so I think I talked about the seasonality of the microplastics and why we're looking at that. The other component that we're looking at with that project is how different development patterns affect and waste management um, patterns affect the microplastic concentration. And so there's been a lot of work in Europe and the northern latitudes looking at the same sort of thing. But there's a lot of assumptions that go into these global models when they're looking at how waste is transported from land out to the oceans and all of that. And sort of those assumptions, because the vast majority of our research has happened in the northern part of the globe. And so we sort of have these data black holes where there's no field data out there to really validate these models and confirm or make corrections to these assumptions. So the second part of my work is looking at building that sort of a data set for Cambodia to say, okay, with these like population densities that we have, with the type of development and agriculture that's in these watersheds, and with the waste management practices. Like in some areas, there's no waste management available at all, and everyone is, it's up to the individual person to manage their waste. Um, if we can understand how those patterns affect or don't affect the microplastic concentration in the river and the link to these larger plastics, the macroplastics, then that can really help. It can really help inform the models that are looking at how plastic trash moves around the world, and it can also um, help as we're thinking about mitigation and planning tools and infrastructure development that can really help protect our water systems.
So you've talked a little bit about the big picture. You've talked
Yeah.
about how you've collected the samples, and I believe what you are measuring is essentially the concentration of the microplastics. And then I would assume also the identification of the microplastics from the additives that are in the macroplastics. So then my question to you is sort of what analysis techniques are you using with respect to instrumentation, or I mean, anything beyond that, now that you have the samples, what are you doing with
Yeah.
them, right?
So the first thing we need to do in the lab is, well, I'll say also I'm not looking at additives right now, but I'll get into that. So the first thing that we do when we get our samples back, so we collect on filters. We use stainless steel filters, sort of a stacked filter method, because we can't transport water internationally. Um, so and the other thing, using this, we call it a high volume sampling method. Rather than doing a grab sample, where you just you take a container and you literally just scoop up water from a site that you're curious and then you take it back to study. That's a problematic method for microplastics because in most water bodies, the concentrations of microplastics are pretty low, like less than 1 to maybe 5 particles per liter. It's pretty low in the US in a lot of areas, and even in the ocean, you know. But, so we use this high volume sampling method because it allows us to filter like 60 liters or up to 100 liters through these filters and then knowing how much we pumped through and looking at the total number of counts we can get particles per liter, which is usually the unit that we're reporting in. But once we get our filters back to the lab, we have to remove all the organic material that could be on them. So we do like oxidation or digestion in the lab to get rid of those. Try to break down as much of the organics as we can without harming the plastics, because we don't want to change the plastics or make them degrade further. And then we also need to remove the sediments that are accumulated on those filters as well. So especially in like a high sediment load river like the Mekong, when our smallest filter is about 20 microns, and those fine sediments that just stay suspended in the river, they just get trapped on that. So you end up with this mud cake on your small filter that you need to try to get rid of somehow. You need to try to separate your synthetic particles from those natural particles. So we do a density separation where we use like different salts with known densities in columns, and then we can separate the plastics that we want. If we fine tune our density of our salt solution, then we can get, theoretically, we can get our plastics to float and the sediments to sink out, and then collect the plastics from that, and then move on with our analysis. I say theoretically because sometimes those particles are bound to the sediments. They aggregate in the river itself. They'll just bind together, or they'll start developing biological crusts on the outside of them and biofilms. And then they get heavy and they sink and they act like a sediment particle. So that's one of the challenges, really, especially with those very small particles, is trying to separate them from natural materials. So knowing that we can't do it entirely, we use a Fourier transformed infrared spectroscopy, or FTIR, to identify the material once we've processed in the lab. Um, that instrument itself really uses infrared light, and it shoots infrared light at a designated spot. Like, we can zoom in really close within a couple micrometers. I think the limits of the instrument is about 20 micrometers is what we can realistically identify. So we can zoom in on our particles and map out where the ones we're interested in, and then we tell the instrument to shoot infrared light at them, and then it measures based on the vibration of the light as it comes off of those particles. It uses that signal to make sort of a fingerprint or a spectra for those material types, and we can compare the spectra of what we are looking at under the microscope against these libraries of known materials. And we can identify particles like that. So for the most part, that's successful. We have been really lucky to work with some brilliant folks behind an open source microplastic identification spectral library called OpenSpecky. So shout out to OpenSpecky. They have been working really hard to build a library of particles that's accessible to everyone. They're constantly updating it, and that resource has been huge. It's over 20,000 different plastic spectra and natural material spectra that are included in that. So that's a huge resource, and that's what we do. So we clean up our samples in the lab, our filters in the lab. We isolate those microplastics, and then or those synthetic particles or whatever else we can't get off the filter. Then we take it down to the microscope, and if there's less than 500 particles on a filter, we'll collect all of them. If there's more than 500, we subset. So we'll take about 20% if it's more than 500 particles, about 20% of the total particles, and we identify those, and then we extrapolate for the rest of the filter.
And that's for characterization in addition to concentration quantification.
Yeah. Well, so we'll use that to come up with our concentration, because before that, we don't know for sure what those particles are. They're so small, and in the Mekong, they're all brown. Like, you can't look at them and say, "Ah, that's a plastic." It all looks the same. Visually, it's really difficult to distinguish, colors especially. Sometimes we'll have material that have a color that pops out and it's bright, but in my examples, that's usually an indication that it hasn't been in the river for a very long time, and it may be contamination as well. So we always collect blanks, um, when we're in the field and then also in our lab processes. And a blank is where you, um you do the same process that you would do um, for your sample, but you don't actually have a sample. So for a lab blank, I would be pumping ultra pure water through my same setup that I use in the field, handling it exactly the same, and then ultimately taking that filter and taking it back down to the FTR and just seeing, did I cause any contamination? Is there anything on there that I need to account for to make sure that my numbers are realistic or not contaminated? So, yeah, the FTIR is a huge important component of our analysis because, especially with mine, without it, we really couldn't tell what's plastic and what's natural.
No, that's really fascinating. I think what keeps you up at night with your research? What is kind of one of the biggest challenges that you face right now?
Yeah. Um, that keeps me up at night. I think, and you probably would hear this from a lot of people working on plastic pollution, is the scale of the problem and the feeling that um, it's going to be a long time before we hit our peak pollution level. So, as I said before, the microplastics, for the most part, are coming from the degradation of these larger materials that are out there in the environment. And those materials, like, if you think about the lifespan of a plastic, like a plastic bottle, we can estimate that can last for up to 400 years out in the environment. Um, 600 for fishing line. Some things are shorter, have a smaller time, but often that just means the time until we can't see them anymore, which doesn't mean that those particles are um, completely uh, broken down. It's the polymers themselves that are still intact, those chains that are the plastic, and they have the same characteristics of the plastic and they act in the environment the same way. They're just smaller and we can't see them and we can't manage them. So right now, globally, the level of plastics that we recycle is about under 9%. So that means practically every plastic plate you've ever used, every plastic water bottle, every plastic bag, it's all out there still. It's in dumps if we're lucky, or it's mismanaged and it's leaked into the environment. And now it's going to be out there breaking down and making more microplastics. And the reason that's scary is because once they get that small, we don't have a good system yet for removing them from the environment. And we're only just now beginning to understand the potential effects of those particles. And so I don't work in ecotoxicology, but there are lots of folks very frantically studying this issue to try to understand what are the effects of these man-made materials on the environment, especially once they accumulate and start reaching high concentrations. So a lot of the studies right now have shown that if there are high enough concentrations of these plastics, it can have um, adverse consequences on aquatic species like plankton, um, uh, photosynthetic algae, mussels, things like that. We're seeing the effect of plastics on their nervous system and their reproductive system at high concentrations. So one of the criticisms of those research will be, well, we're not at those concentrations right now. But the answer to that is we might be soon. Because right now we're just generating more and more plastic year over year, and we're not managing it well, and we don't know how to get it out of the environment. So I'm collecting all this data, trying very hard to um, add meaningful knowledge to our base so that we can make good decisions, but also feeling like um, the clock is ticking. And every year we're just generating more and more and more plastic. Year over year, we're increasing the rate of production. And especially as the world shifts from oil in cars, most plastics are a byproduct of oil and gas refining. So as we shift away from using fossil fuels and for transportation and energy, the industry is pushing hard to replace that use with plastic production. And it's hard to argue for a lot of folks who are in the retail end of things because it's so much cheaper than everything else. It's an incredible plastics are an incredible material. They're lightweight, they're durable, they're versatile. You can do just about anything with them. And they're also really, really cheap. Um, but they don't go away and we don't manage them. And we need to consider the consequences once it's out there in the environment. So, not quite related to what about my data is keeping me up at night, but related to the field that I'm working in. Um, that's one of the things that I think about a lot. Just hoping that the material, the data that we're collecting will be used by policymakers and people who can really make a difference in changing our business as usual to something that is more sustainable and that we can protect. We can protect the species out there that happen to be sharing this space, this period of time with us in our evolutionary history.
Well
Um,
said. Well said. Um, Last question, and I ask all of my guests this question before we exit is, if you were to tell yourself 10 years ago, 20 years ago, when you were a kid, or young adults in your case, and you would impart some wisdom to yourself, hindsight being 2020, what would you tell yourself?
oh, I don't know. I don't know that I would change anything. I had a bumpy process getting to where I'm at. Definitely didn't take the usual path. But I learned so much on the way and I developed so much as a person. It's um, hard to say if there's anything I would tell myself to change or avoid. Um, but I would definitely say to stay curious, to keep digging, to don't settle. If you're not if you're not doing the thing that you love, you can change. You can keep hunting and nothing is ever decided. So I think those are the probably the words of encouragement that I would give my younger self is like nothing is forever. You can always change, you can always grow. There's no reason to stay stuck. And if you're feeling stuck, make a change.
And everyone, you heard it directly from our soil expert. Don't settle. Anyway,
Yeah, I like it.
terrible. But thank you, Rachel. Thank you for the discussion today. Your path may
Thanks so
have
much
not
for
been
having me.
non-traditional, but you know what? I think it's fascinating all the more, and I think there are a lot of different things, and not everyone has to do the same thing. And you learn through all of your different experiences, which you obviously spoke a lot about. So I thank you for being a guest, and I thank our listeners for obviously tuning in. And always ask yourself, where does your journey stem from? Thanks, everyone.